so let us start that laws of motion. So in this particular chapter, laws of motion, we will study under these following headings. So the first one is that law of inertia. Its historical aspects also. Then we will study Newton's laws of motion, means Newton's first law of motion. Then we will be studying momentum. Before studying Newton's second law, momentum is there. So we will be studying momentum. And then fourth, we will study Newton's second law of motion. Fifth, we will study Newton's third law of motion. Right? Sixth, we will be studying impulse. Actually, impulse will be coming after Newton's second law only. No problem. So, impulse we will be studying. Then seventh, we will study friction. Friction. And eighth, in this chapter, we will be studying that you can say friction on a straight road and banked road. So vehicle moves on the road, so there will be friction. Okay, so how it will be there? What will be the friction when the vehicle is traveling on a straight and level road, and what will be there when it is traveling in banked road? So you would have seen that when you are crossing any flyover and all, so that flyover is one side, it is banked like this. Okay, so at some angle. So why that angle is? Okay, so that part we will be studying on this bank road. Right. So let us start our discussion. So our discussion starts from that inertia. So Aristotle was there. So Aristotle, what he told? Aristotle. Okay. So Aristotle told that to keep the body, any body, to keep the body in motion or in rest. Okay. To keep the body, in motion or in rest, in motion or rest, an external force is required. Okay, what he told, an external force is required. So Aristotle told at that time that to keep the body in motion or rest, an external force is required. Okay, later on this theory could not be accepted, and it was found that external force is not required, and which was found by Galileo actually. Galileo. Right, so Galileo found, and he told that to keep the body in motion or rest, external force is not required. But yes, of course, if the body has to be accelerated, if there is a force, there will be an acceleration. If there is no force, there will not be an acceleration. So the body which is moving, it will keep on moving. The body which is at rest, it will keep on at rest. So what is the funda? What he told, that actually what is happening when we are rolling the ball on ground. So after some time it is stopping. So that stopping of that ball is not taking place due to what, that an external force is applied. It is only due to that frictional force. Suppose in case there is no friction, that ball will keep on moving. Infinitely it will keep on moving only. And that is the only funda behind that why planets revolve around the sun, why moon is revolving around the earth. Correct? Okay. So Galileo, he told that to keep the body in motion or rest, external force is not required. Or to accelerate the body, only external force is required. Okay. So Galileo, he stated that there is no force, there is no external force, actually, there is no external force acting on a body if the body moves with a constant velocity. See, acceleration, when it will be there? When there will be change in velocity. When there is a change in velocity, then only acceleration will be there. So if there is no change in velocity, with constant velocity it is moving, then there is no external force acting on the body. If the body moves with a constant velocity, or it is at rest. It means what? If we want the body to accelerate, then an external force is required, otherwise it is not required. Okay, so this statement of Aristotle was totally ruled out by Galileo, and he conducted some experiment on double inclined plane. Double inclined plane. So what is this double inclined plane? Means this type of plane. So what he told that suppose if a ball is taken to this much height, okay, and if it is released, so it will be climbing in that next plane. This is the other inclined plane. This is one of the inclined plane. This is another inclined plane. So this ball will be climbing up to the same height what it is having here. If it is frictionless, so it will roll here and it will be climbing up to the same height. So this height will be maintained, same height. It will be climbing. Correct? Okay. Now another experiment what he conducted, he increased the inclination of this one, slope. So what? He took like this. Right. It should be inclined only. Took like this, and he made more hair angle. Slope is more than this one. Yes or no? So in this one also, if a ball is moved up to this much height and if it is left, okay, so now this ball will be rolling and will be climbing up to the same height, though it is covering more distance. Okay, with respect to this one, it will be covering more distance. Here you can say that here only this line is getting inclined, whereas in this case it is taking some more time to get inclined. Though it is covering more distance here, then also more distance here, then also it will be reaching up to the same height. The ball will be reaching up to the same height. Though it has to cover more distance, no problem. It will be covering more distance. That is only telling that if, and another experiment what he did, that inclined plane he took single inclined plane and he kept it as horizontal. Simply horizontal level, like this. Then what he found, that if the ball is taken up to this height and if it is released, so that ball keeps on moving. The ball will keep on moving up to infinite distance, keep on moving. Okay, here it will not stop if we will ignore these frictional forces. If it is a frictionless surface, it will keep on moving. Full life it will keep on moving. That is the funda what he told, that there is no external force required for keeping the body at rest or in motion. And then later on, theory for earth revolution around the sun, moon revolution around the earth, all this theory came. Okay, so this was there. Now, so this was double inclined plane. You have understood now? Okay, right. So with the theory of this Galileo, actually a good form was given by Isaac Newton, Okay, so in a single theory, whether you have rotated on this one? Okay. So actually Galileo only said that inertia. So this inertia, so what Galileo stated, that a body which is at rest or in motion without any external force, free from any external force, okay, tends to oppose its state. Its state means if it is moving, it will keep on moving. If it is at rest, it will keep on at rest. So it will oppose. Okay, it will not try to move of its own self. Correct? And if it is moving, it will not stop of its own self. Okay, so that only Galileo stated, that a body which is at rest or in motion, free from any external force, tends to oppose its state. Okay, so this resistance to change the state of a body is called inertia. So if the body is having mass, due to mass it will be having inertia. Means it will be keep on at one place. Okay, right? Whether you have noted down this one? So then Newton, means Isaac Newton, his full name was Sir Isaac Newton. So you can say that one mechanical law of mechanics is being given by Galileo, and Sir Isaac Newton, he brought or formulated the mechanics and stated the law after combining all the theories of Galileo into a single law, which is called law of inertia or Newton's first law. Okay, this single law is called law of inertia or Newton's first law, motion. Newton's first law of motion. Okay. So in this Newton's first law of motion, what it is, the statement, every body, okay, so every body continues to be in a state of rest or in motion unless compelled by an external force to act otherwise. Understood? So Newton's first law of motion says that every body continues to be in a state of rest or in motion unless compelled by an external force to act otherwise. To act otherwise means what? If we are trying to stop it, if we are trying to accelerate it, okay, then only its position will be getting changed, its state will get changed. State doesn't mean that its position, displacement. Okay, state means here whether it is moving or whether it is static, static or dynamic. Understood? So what state we are referring every place, this state actually is referring to its motion or rest. Motion or rest. Right? Okay. So whether you have noted down this one? Right. This statement can also be written as in absence of any external force on a body, the acceleration of the body is zero. Okay, so sometimes you may be asked that in this way, whether the acceleration of the body is zero. Okay, in absence of any external force on a body, it means what? To get acceleration, we need one external force. It means to have acceleration on a body, an external force is needed. Okay? Very good. Right. Can I have this side? Okay. Okay.